ask others to join the class immediately. Please remind them.
Good afternoon, sir.
Yeah, good afternoon. Yes, shall we start? Still some students have not joined. Yes, shall we start the class? Only 50 were joined. What about others? CR is there. CR, are you available?
Yes, sir.
What about others?
Sir, let's begin the class. They will come.
Okay.
Good afternoon, sir.
Hello. Hello, Anandji. सोनिकेटर है? Yes, we are having सोनिकेटर. Yes, probe वाला भी है. We are having probe. Actually, that is Mahapatra sir is using that. Mhm. Yeah, good afternoon. Good afternoon, everyone. Sorry for the late. Yes, okay, once
Good
again.
afternoon. Good
Yeah,
afternoon, sir.
Yeah. Yes, you would like to say something?
Yes, sir. I say good afternoon, sir.
Okay, thank you. Okay, Sumran Kumar. Today's applied chemistry, how many units are there?
4.
Sir,
Units.
4.
4 units are there. Unit 1, yes, speed up.
Technology of water.
Technology of water,
Unit
sir.
2,
Fuel
Corrosion and cement.
fuel combustion and cement. Unit 3,
Corrosion and
Corrosion and phase.
yes. Unit 4,
Lubricants and
Lubricant and polymers.
yes, polymers and lubricants. Okay, till now, the technology of water has been completed. And the second one is fuel combustion and cement portion has been completed. And the third one is phase rule has been completed and about to complete the corrosion portion, I think. corrosion portion, the remaining leftover portion was completed or not?
The corrosion was started, but the network issue it was not held.
Arey.
You were telling
I think,
factors
yes,
affecting
okay, the
corrosion.
madam spoke to me, then I gave some PPTs, then I, okay, given some guidance also, madam, okay, at the earliest you complete the, okay, portion. She, herself, she said, sir, I will continue the corrosion only, please you start the new unit. Okay, I said, okay. Yeah, corrosion, see, there are 4 to 5 topics are there. First one is what is corrosion and different with what are the different types of corrosion, dry corrosion and wet corrosion. That means dry corrosion, then chemical corrosion, wet corrosion, that is the electrochemical corrosion. Then what are the different types of electrochemical corrosion? Then the mechanism of rusting of iron, that is comes under electrochemical corrosion. Then different types are there, pitting corrosion, okay, crevice corrosion, underground corrosion, waterline corrosion, galvanic corrosion, different types are there. Then after that, factors affecting the rate of the corrosion, factors affecting the rate of the corrosion. There are nature of metal, nature of environment. Then after that, electrochemical series, galvanic series is there. Then after that, protecting measurements against corrosion. What are the protecting measurements against corrosion? What are there? Designing of metal, selection of metal. Then after that, anodic. Teach us this topic if you have enough time. Sir, can you teach us that topic? See, after some time we will teach. See, don't worry. Even I will take one extra class. I will complete the portion. I will revise the portion. Don't be hectic. Today I am going to start the polymers, but just for quick revision, I am teaching. Just I am revising all these. So in the protecting measurements against corrosion, designing of metal, selection of metal. Then after that, designing of metal, selection of metal. Then coatings, protecting coatings. Then cathodic protection. In the cathodic protection again, the sacrificial anodic protection. Then after that, impressed current cathodic protection. Okay, these are the things are there. Okay, this part madam will cover. If left over, I will cover it. Don't worry. Okay, now today's our topic is polymers. Yes, this PPT is okay. Are you visible? Are you able to see the PPT?
Yes, sir.
Yes, sir.
Yes,
sir.
See, what is polymer? See, polymer means, what is the title itself we can understand. See, poly means, polymer is a Greek word. Poly means many. What does it mean? Poly means many. Then mer, M-E-R, mer means units. Mer, M-E-R, mer means unit. That means poly means many, mer means units. That means polymer means many units joined together and they are going to produce the bigger molecule. That molecule is called as polymer. Then such type of reactions are called as polymerization reactions. That's it. Look into title only we can understand. What is the definition of polymers? Polymers means poly, many, mer, units. That means many units. So the small units may join together and they are going to produce the bigger molecule. They are going to form the bigger molecule. Such type of molecules are called as polymers and such type of reactions are called as polymerization reactions. Now, see here, normally I am giving one statement. All the polymers are macromolecules. Once again, you listen. All the polymers are macromolecules. That means bigger molecule. Macromolecules means bigger molecule. But not all the macromolecules are polymers. समझ लो. All polymers are macromolecules. But all macromolecules are not polymers. Because in the polymers, there are repeating units are there. Systematic arrangement of the small molecules that leads to bigger molecule. But whereas in the macromolecules, simply the combining of different units that leads to bigger molecule. So there is no repeating units. Say for example, I can give one example. Polythene is there. Polythene, how that is produced? By the reaction of many number of ethylene molecules. Many number of small molecules like ethylene molecules may join together, and that ethylene molecules are going to produce the polythene. So polythene is the one of the polymer. In that, what are the small molecules? Ethylene molecules are the small molecules. So that small molecules are called as monomer. Ethylene is called as monomer. That means many monomeric units join together and they are going to produce the polymer. That means here what is the repeating unit? The monomer. That means ethylene molecule is the repeating unit. Hence, so all the polymers are macromolecule. That means size is bigger. But not all the macromolecules are not polymers, because in the macromolecules no repeating units are there. Are समझ में आ गया this difference?
Yes, sir. Yes, sir.
Be active, please. Be active. I may slightly fast. So
Yes, sir. I understand.
All polymers are macromers and all macro are not polymers.
yes. Yes.
Tenzin
Now-
are so excited.
Huh?
Sir, motivate, sir. Sir, motivate me, sir.
Okay. Yeah, next one is, next our topic is, here some introduction is there. This introduction is not required. This is our information and knowledge purpose. So because of, as we are running with shortage of time, the introductory portion I am skipping. This is knowledge purpose. So please, I am going to share this PPT. You go through this, don't get tension. This is only information and knowledge purpose. Now, I am going to discuss here, the title it was there, classification based on polymerization. That means here you can treat this as, types of polymerization reactions. Here I think, this is some, image was copied here, but here you can treat this as, types of polymerization reactions. Simply types of polymerization reactions. Okay. So types of polymerization reactions. Our next topic is types of polymerization reactions. Now, in the types of polymerization reactions, first one is addition polymerization. In the addition polymerization, what happens? The small molecules may join together, and that is going to produce the bigger molecule. This is the addition polymerization. That means in the addition polymerization, what happens? There is no elimination of small molecules. There would be no elimination. Simple. All the ethylene molecules, the reaction of ethane is alkyne. The reaction of ethylene, the more number of ethylene molecules may join together, and that is going to produce the bigger molecule. That is the polythene. CH2, that is the polythene. That means this is the addition polymerization reaction. In the addition polymerization reaction, what is happening? The more number of ethylene molecules may react with each other, and that is going to produce the bigger molecule. That means in the addition polymerization, the more number of monomeric units join together one by one, and that is going to produce the bigger molecule. That is the polythene. Okay, now see here what happened. The next one is condensation polymerization. In the condensation polymerization, what happened? Different monomeric units. In the addition polymerization, what happened? Same type of more number of monomeric units. Same type. That means ethylene. Ethylene is the monomeric unit. All the ethylene molecules may join together. That is going to produce the bigger molecule without elimination of any small molecule. But whereas in the condensation polymerization, what happened? Different types of monomeric units. Different types. Here, what are the different types? Yes, here, hexamethylene diamine, CH2, NH2. This is the hexamethylene diamine. Then here, tetramethylene dicarboxylic acid. This is the adipic acid. Normally, this is the adipic acid. So, the reaction of hexamethylene diamine, then tetramethylene dicarboxylic acid. This is one monomeric unit. This is the another monomeric unit. This monomeric unit is having the amine functional group. This monomer unit is having the carboxylic acid functional group. So the reaction of amine with carboxylic acid, that is going to produce the nylon 6,6. See here it is. This is called as nylon 6,6. Why nylon 6,6? Because here how many number of carbons are there? 6 carbons are there. Here carbon 6. Then here also CH2 4. That means 4 carbons. Here this is 5. This is 6. So total 6 number of carbons are there. That means in the 2 monomeric units, here also 6 carbons are there. Here also 6 carbons are there. Hence, it has given the name as nylon 6,6. So in the nylon 6,6, what are the monomeric units? The hexamethylene diamine and tetramethylene dicarboxylic acid, that is going to produce the one nylon 6,6 polymer. See here what happened. See here in the NH2, one H is there and here OH, another OH is there. So the reaction of the one hydrogen from amine, then hydroxy group from carboxylic acid, then that is leaving as a H2O. See here, H in the NH2, H is there and here OH is there, H2O is there. So by the elimination of H2O, that is going to produce the nylon 6,6 polymer. That means in the condensation polymerization, what happened? Different types of monomeric units may join together. They are going to produce the bigger molecule by the elimination of small molecules. You keep in your mind. In the condensation polymerization, some small molecules are eliminated, whereas in the addition polymerization, no elimination will take place. So please you keep in your mind. Somebody are calling. Okay, abhi class busy hai, baad mein receive karenge. Okay, now next one is copolymerization. What is copolymerization? Actually in some textbooks they are writing what is copolymerization. In the copolymerization, what happened? Styrene butadiene rubber. Okay, styrene butadiene rubber. Styrene butadiene rubber. Okay, this is one of the best example for copolymerization. In the PPT it was not written, but here that example I am showing here. Copolymerization. So in the copolymerization, what happened? The reaction of styrene with butadiene. Okay, 8 minutes. It may be some important call. Hello. 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 In the copolymerization, what happened? The reaction of styrene. What is the styrene structure? Okay, here it was not written, but here styrene structure is, this is the benzene structure, CH double bond CH2. Hello. Yeah, good afternoon. Yeah. Yes, madam. Actually, I'm okay. Slightly busy. I'm taking one class. Could you please call me in the evening hours? Okay. Yeah, after 5:30 you can. Yeah, after 5 o'clock. After 5. Yeah. Please. Okay. Yeah, copolymerization, what is happening? There are 3 types of reactions are there. Normally, in most of the textbooks, they wrote only 2 types of reactions: addition polymerization, condensation polymerization. But some textbooks, they wrote copolymerization. What is copolymerization? Here also same, different monomeric units may join together without elimination of any small molecules. That means here one styrene is there. What is the styrene structure? One styrene structure is benzene CH double bond CH2. Then 1,3-butadiene CH2 double, okay, CH diene, okay, CH, then double bond CH, then okay, single bond CH double bond CH2. This is the another 1,3-butadiene. So this is the 1,3-butadiene. The 1,3-butadiene is reacting with styrene. Then that is going to produce the styrene butadiene rubber. That means, see here, okay, up to this part only, okay, one polymer. So this is one, then this is the another one like this. So that here what is happening? in the addition polymerization, same type of monomeric units they are joining. Then similarly, in the copolymerization, what is happening? Yes, simple. The monomeric units are joining, but here different monomeric units. What are the different monomeric units? Styrene and as well as butadiene. The reaction of styrene structure, benzene, CH double bond CH2. That is the styrene. 1,3-butadiene. What is the 1,3-butadiene? CH2 double bond CH, single bond CH, double bond CH2. This is the 1,3-butadiene. So the reaction of styrene with butadiene is going to produce the styrene butadiene rubber, SBR rubber. So this is also one of the example for copolymerization. See, copolymerization, no elimination of byproducts in like addition polymerization, but whereas in the addition polymerization, same type of monomeric units are joining together, but whereas in the copolymerization, different monomeric units are joining, and that is going to produce a bigger molecular weight compound. But whereas in the condensation polymerization, different monomeric units are joining, but by the elimination of small molecules, they are going to produce the bigger molecule. Okay, so here in this amide linkage is there. Here NH, here this is the amide linkage, NH and CO. Okay, amide. This is the amide linkage. See how amide linkage? Here H and here OH. So H2 is eliminated. So NH single bond CO. That means NHCO, amide linkage is there. So in the nylon 6,6, which functional group is there? Amide functional group is there. So there are more number of examples are there. So please you go through the textbook, polystyrene, like that. Number of examples are there. Yes, sorry for the disturbance. Yeah, next one is where we are, yes, types of polymerization reaction, addition polymerization, condensation polymerization, copolymerization, it is over. Now, next one is plastics. Our next topic is plastics. See, what is the definition of plastics? Here molecular force, some examples are there. So, okay, that you don't worry. Now, next one is plastics. What is the definition of plastics? See, the polymers, okay, which can be molded into desired shape by the application of temperature. So such type of polymers are called as plastics. Actually, that was not there. So simply, okay, here online, okay, I'm showing something. What is that? Now next one is what are the plastics? What is the definition of plastics? See, okay, here also the definition was not given. Okay, it's okay, no problem. See, first of all, what is the definition of plastics? Our next topic is plastics. The definition of plastics is the polymers which can be molded into desired shape by the application of temperature is called as plastics. I don't know the PPT, it was not clearly made. Still no problem. What is the definition of plastics. Plastics means the polymers which can be molded into desired shape by the application of temperature. That is called as plastics. Polymers, what is the definition of polymers? That was over. That means many units join together to produce the bigger molecule. That is called as, that molecule is called as polymer. Such type of reactions are polymerization reactions. And similarly, in the plastics, what is the definition of plastics? Plastics means the plastics are also polymers, but they can be molded into desired shape by the application of temperature. That means in presence of temperature, the plastics may be converted into different shapes. So such type of polymers are called as plastics. Now, the plastics are two types. What are those? Thermoplastics, thermosettings. What are the thermoplastics and what are the thermosettings? It was given here. See, first one, there are two types of plastics are there, thermoplastic and as well as thermosetting polymer. What is the definition? What is the difference between thermoplastics and thermosettings? See, thermoplastics can be synthesized by the process called addition polymerization. That means the polymers which can be synthesized by addition polymerization, they are comes under thermoplastics. Now, here in the thermosetting polymer, they are synthesized from condensation polymerization. That means the thermosettings can be synthesized by condensation polymerization reactions. Then here, this fellow also not given good difference. Here it is okay. Yes. See here, thermoplastics, first one, thermoplastics. Then next one, thermosettings. Now, these are formed by the addition polymerization. These are formed by the condensation polymerization. Now, here they are the linear and slightly branched long chain polymers. Most of the time, linear things are there. But whereas in the thermosettings, cross-linked polymerization may be there. Cross-linked cyclization may be there. Now, they can be easily softened on heating and hardened on cooling. Thermoplastics, that means in presence of temperature, these plastics can be molded into desired shape because by the application of temperature, they are getting softening. As they are getting softening, they can be converted into desired shape. That means they are getting the plasticity on heating. Now, next one is they cannot be softened on heating. Thermosetting polymers, they cannot be softened on heating. That means if you heat the thermosetting polymer, they may burn and that is converted into charcoal. That means that it cannot be softened. So that is the difference between thermoplastics and thermosettings. Actually, this is a very, very important point. Thermoplastics can be molded into desired shape by the application of temperature. But whereas thermosettings, see, setting is there means they cannot be remolded, they cannot be reshaped, they cannot be recycled. But whereas thermoplastics are, they can be remolded, reshaped, recycled. Please keep in your mind. Thermoplastics, plasticity will be existed. Thermosettings, setting means once it is generated to any desired shape, then it cannot be bring back. Once it is synthesized means, but that shape will be like that only. It cannot be remolded. Then next, here in the thermoplastics, van der Waals forces are there, but whereas in the thermosettings, strong hydrogen bonds are there, covalent bonds are there. Here van der Waals forces, covalent forces. So because of the van der Waals forces, in presence of temperature, they are softening. But whereas due to covalent bond, they are very strong. It cannot be softened. Then by nature, they are soft, weak and less brittle. But they are strong and more brittle in nature. More brittle means easily breakable. Now, their molecular weight is low, their molecular weight is high. Then they are quite soluble in organic solvents. They are insoluble in organic solvents. They can be remolded into desired shapes. They can be remolded. They cannot be remolded. Now, monomers used here do not have more than 2 reaction sites. Yes, but here used have here 2 reaction sites. Reaction site means, see, what are the reaction sites? Say for example, ethylene is there. If this double bond, what happens in presence of catalyst or in presence of temperature, the double bond may break down. Then this side, the functionality will be there. That means one carbon may get positive charge, another carbon may get negative charge. So bifunctionality would be there, maximum. But whereas, okay, in the condensation polymerization, see here, amine, this is one functional group, amine, here also one functional group, carboxylic acid, carboxylic acid. That means different functionalities are there. So different functionalities are there, functional sites are there. So at any time, the monomer unit may join. So cross-linking may take place. But here in the thermoplastics, linear cyclization will take place. Linear reactions will take place. But in the thermo settings, cross-linked cyclization will take place. Then, okay, what are the examples? Okay, polythene, polystyrene, polyvinyls. That means polythene, what is the monomer unit? Ethylene. Polystyrene, what is the monomer unit? Styrene. Styrene means benzene CH double bond CH2. Then polyvinyl. Polyvinyl means vinyl chloride. That means CH2 CHCl. Okay, that is the vinyl chloride. But here, okay, what are the best example for thermo settings? Bakelite. Okay, bakelite is the one of the example. That means the reaction of urea with formaldehyde. Okay, reaction of urea with formaldehyde. That is going the 3 moles of formaldehyde with urea. That is going to produce the cross-linked polymer. That is called as bakelite. Then urea formaldehyde resins. These are the some of the examples of thermo settings. अरे समझ में आ रहा है कि नहीं आ रहा है?
Yes, sir. Yes, sir.
Yes,
It's okay?
Sir, please repeat.
Yes, sir.
Sir,
Yes, tell.
You told about reaction sites. Once again, tell.
Which reaction?
Like thermoplastic has only 2 reaction sites and thermosetting has more than 2 reaction sites. What are those reaction sites?
Reactive sites it is having more than 2 reactive sites. See, monomer used here have more than 2 reactive sites. That means more number of functional groups are there. So as more number of functional group means that functional group itself, it is acting as a, but that is only your doubt.
Yes, sir.
Okay, now understood this topic?
Yes, sir.
sir, on heating, it becomes softening, thermoplastic in thermo setting. So, what does it mean, sir? Softening means?
Softening means it is the plasticity nature is reappearing. See how we are doing. Simply they are collecting some plastic material, they are heating, then that is converted into liquid. Then that liquid, if it is poured into any shape, क्या बोलते हैं इसको, some models are there. So in that model, if that liquid is poured, then what happens? That plastic that liquid is getting that desired shape. Then on cooling, that would be get hardened. Okay. So say for example, initially you made chair. Let us assume that one plastic chair is there. Then after some time, it was broken. That handle was break down, or that leg was broken. Okay, anything. So what happened? Then that waste material you recollect it, then you crush it, then you heat it, then that chair is converted into another table. Okay, instead of chair, you can make it kids table, or otherwise from that plastic you can make it another plastic toy. So this is the remolded, reshaped, recycled. That is comes under thermoplastics. But whereas in the thermo settings, what happen? On heating, it cannot be softened. If it is not softened, you cannot reuse for the manufacture of other items. समझ में आ गया कि नहीं आ गया?
Yes, sir. Understood.
The copolymer of butadiene and styrene, that comes under which category, sir? Thermoplastic or thermosetting?
SBR comes actually SBR styrene, butadiene, rubber. That means that is comes under elastomers. समझ में आ रहा है ना? Next topic is our top. Next is elastomers. Okay, see, SBR, styrene, butadiene, rubber. Rubbers means elastomers. Elastomers, what is the definition of elastomers? The polymers which are having elasticity nature more than 300%, such type of polymers are called as elastomers. So, SBR is comes under elastomers, but that may be generated due to the reaction of styrene with butadiene. So that is called as copolymerization reaction. समझ में आ रहा है?
Sir, in bakelite, which type of monomer is present? In bakelite, sir? Bakelite.
Sir,
Oh,
what are the
bakelite,
monomers
urea,
of
reaction of urea with
What are the
formaldehyde.
monomers present inside the bakelite, sir? Bakelite is a
Inside the-
polymer. Sir, I can say, I am asking to you, in bakelite, which type of monomer is present? Because bakelite is a polymer.
अरे आप क्या you're not listening class, I think so, Sumran Kumar. I said
I
the
listening,
reaction of-
sir.
Huh?
What you are teaching, I listening clearly. But I am asking,
I
sir,
said-
कि
सुनो Sumran. I said the bakelite is one polymer that is produced due to the reaction of urea with formaldehyde. The reaction of urea, NH2C double bond O NH2, that is the urea. Then formaldehyde, HC double bond O H, that is the formaldehyde. The 3 moles of formaldehyde with urea, that is going to produce the Novolac. Then on reaction of with hexamethylene triamine, then that is going to produce the bakelite, that is a cross-linked polymer. That means simply you remember that the reaction of urea with formaldehyde, that is going to produce the bakelite. So in the bakelite, what are the monomeric units are? Urea and formaldehyde.
Oh my
But
God.
formaldehyde also specifically you have to mention 3 moles of formaldehyde. Okay? 3 moles of formaldehyde, the reaction of 3 moles of formaldehyde with 1 mole of urea is going to produce the bakelite. The bakelite is the cross-linked polymer. समझ में आ गया?
yes, sir. Understand.
Or any doubt? Yes, do you have any doubt?
Sir, I think phenol with formaldehyde gives bakelite, sir.
Huh?
Yes, sir. Yes, sir.
Phenol with urea with formaldehyde gives monoamine.
Urea?
I think phenol and formaldehyde gives bakelite, sir, not urea and formaldehyde.
Yes, phenol. Yes, you are correct. The reaction of phenol with 3 moles of formaldehyde. Yes. Correct, yes. You are correct. Where is that reaction? Yes, the phenol with formaldehyde. The reaction of phenol with formaldehyde is going to produce the orthomethyl phenol, then paramethyl phenol, then that is going to produce the Novolac, then the Novolac is going to produce the bakelite. The bakelite is the cross-linked polymers. Yes, that is correct. Here the reaction is not showing.
Sir, urea is not here, no? Inside the
Not
bakelite,
there,
urea is
not
not
there.
present.
Urea-
Phenol and formaldehyde is present.
Yes, sir.
Yes.
Yes, phenol and formaldehyde only.
Yes. Okay.
Okay. Yes, Yachna Chaudhary, why you were joining late?
So I got disconnected in between.
Okay, here also it was not given. Yes, Yachna, why you were, okay, you were joined late?
So I got disconnected in between.
Okay. Yes, see here, this is the reaction. The reaction of phenol with formaldehyde, but the formaldehyde is 3 moles. Normally, the reaction of phenol with excess moles of formaldehyde. They used to write, but excess moles means how many moles? 3 moles. You remember this one. Okay. Yes, see here, the reaction of phenol with formaldehyde is going to produce the orthomethylal then paramethylal. Then that orthohydroxymethylal or otherwise para-hydroxymethylal, they may undergo polymerization and that is going to produce the Novolac, that is a linear polymer. Then that Novolac may react with 1 mole of formaldehyde, then that is going to produce the Bakelite. This is the cross-linked polymer. That means, see, this is the orthomethylal. So here CH2OH is there, here H is there, H2O is eliminated, then methylene is there. Then similarly, here OH, CH2OH, that OH and here H. So, okay, this is one of the cross-linked polymer, that is the Bakelite. It's okay? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
ये कौन है? वैभव कुमार कौन है? क्या लिखा है?
Yes, sir. Yes, sir.
Oh, here you wrote something. What is this? Chill? CHL?
Nothing, sir.
Huh? Vasudev Mishra. N means? Hello? Vasudev Mishra, come to video mode.
Sorry, sir, I missed time.
Huh?
Yes.
Vaibhav Kumar, come to video mode.
Yes, sir.
What you wrote, man? Here you wrote something.
Yes, nothing, sir. That's
Huh?
nothing, sir.
What you wrote, man? आपको शायद जल्दी NIT छोड़ना है, हाँ? Who is the CR? CR, come to video mode. Or combined section CR.
Yes, sir, here I am.
Come to video mode.
Sir, actually, I'm joining the class with the mobile phone and the camera quality is not so good, sir. Can you please?
मोबाइल से ज्वाइन करेंगे तो वीडियो नहीं ओपन हो रहा है क्या?
Sir, camera is not quite good. Like, I'm having Galaxy S Next, the older version.
Okay, wow, what is this? What is going on in your class?
Sorry, sir.
Huh?
Sorry, sir.
ठीक है. Okay, this I'm concluding.
Sir,
Okay, one more class is
I'm
required.
apologizing on their part, sir. Sir, I'm apologizing from their part, sir. Forgive us.
It's okay. Please don't repeat. Don't repeat. Don't repeat.
Yes, sir. Sorry, sir.
Okay, be sincere.
Yes, sir.
Vaibhav Kumar,
Yes, sir. Sorry, sir.
109.
Sorry, sir.
Don't repeat this type of things.
Yes, sir.
Okay. Yeah, one more topic is there. That is the vulcanization of elastomers. What are the elastomers? Then what is the monomeric unit in the elastomer? That is isoprene. Okay, very simple. I think isoprene, that vulcanization of elastomers you might be knowing. The natural elastomers is heated in presence of sulfur at 100 to 120 degrees centigrade. That is going to produce the disulfide linkage isoprene units. So that is called as vulcanization. That's it. But still, okay, I think we are getting one more class now. We are getting one more class. Shivam?
Sir, after 3
Yes,
p.m.
sir.
one math classes.
Sir, we are having maths class from 3
Uh-huh.
p.m. Yes,
Maths
sir, we are-
class.
No.
Sir, can we join our math
Next
class?
week we
Sir,
would
from
be
3
having
p.m.
only one
math
more
classes
class.
are having.
Yes, sir. Sir, we will have next
Okay.
week. We are having one class of yours.
Okay, no problem. I'm in a position to complete the portion. Okay, bye.
Thank you, sir.
Thank you, sir.
Attendance taken.
Uh-huh.
Thank you, sir.
Thank you,
Thank you, sir.
Thank you, sir.
Thank you, sir.